This video will demonstrate the use of the new Automated Performance Analysis Wizard tool with the Tunnel Boat Design Program version 8.0. I'm going to assume that you're familiar with the use of Tunnel Boat Design Program, including the data entry and the setup of your design arrangement. These setup procedures are really quite simple, but are also documented fully in other videos. So, let's get right to the operation by going straight to the design file selection screen and selecting our recreational tunnel hull outboard design model. This selection already has all of its design specifications entered properly on the 4 input screens, and we're ready to do the first 2 steps of performance analysis using the new Automated Performance Analysis Wizard. I will go through the Auto 1, 2, 3 analysis process in more detail in a minute, but since we've got all of our design information already input here, I first want to show you just how fast and easy the performance analysis is using the Auto 1, 2, 3 Wizard. Suppose I want Tunnel Boat Design Program to predict my maximum speed and then show me performance as my boat accelerates through its velocity range with the trim angle adjustments all the way. Here's how easy that is. I check the 1, 2, 3 auto box, then click Calc Perform to get maximum velocity. There it is. Maximum limiting velocity is 85 miles an hour. Then step 2, I click Add Vmax, and then click Calc Perform again, and it gives me an automated report that's full of some performance measures and advice that's specific to my hull design and setup. Then I click Details, and I get the full performance output screens that show how my boat behaves through its entire velocity range, and I can see it all in graphic format too. So that's all there is to it. 1, 2, 3 steps, and I get a complete performance picture for my boat. Now let's go back to the beginning, and I'll show you each step again and the performance information that we get along the way. The Auto 1, 2, 3 Wizard is activated on input screen number 3 in the design analysis frame. So I'll just put a check mark in the 1, 2, 3 analysis checkbox. The program is now set to automatically adjust the setup parameters to reach the maximum limiting velocity, and then adjust the trim angle through the full velocity range of the performance analysis. This wizard is really a fantastic tool that makes it so easy to quickly do a complete performance analysis of my hull design, including the maximum speed calc, and then the full performance analysis through my hull's full operating range using maximum power available and then automatically varying the required trim angle. So now I will just click on Calc Perform to do step number 1 of the performance analysis, giving me the maximum velocity limit. The report wizard gives me a summary report telling me that my maximum limiting velocity is 85 miles an hour. It also tells me that the distribution of lift that sponsons and center pod and aerodynamic forces are contributing to the total. Now I'm ready to go to step 2 of the performance analysis, so all I need to do is click on Add Vmax. The Auto 1, 2, 3 Wizard has now already defined for me the maximum velocity and the velocity range steps, and it has set up the performance analysis method to automatically adjust the trim angles throughout the whole velocity range for the performance analysis. Now I can click on Calc Perform again, and I get the completed performance analysis starting with the report wizard. This version of the report wizard is really outstanding. The wizard has reviewed all the performance results for the entire velocity range and has summarized the key performance issues that might be important for my hull's design and setup for me to look at. There's another whole video that explains all about the report wizard results, but I want to have a quick look at some important notes that it's given me for my design here. It's giving me a heads up for some performance issues to look closely at when I look at the performance details and performance graphs later. The first thing it tells me is that the maximum or limiting velocity for my boat is at about 85 miles an hour, and that the trim angle at this speed is 3.7 degrees. But it tells me much more than this. It's really amazing how smart this report wizard is. For example, it tells me that as trim angle is increased for more speed, the biggest change in the trim angle occurs at 78 miles an hour as the boat tries to go faster. So we may be reaching a region of unstable operation above that speed. It also tells me that my hull starts into its hump zone at 49 miles an hour based on dynamic stability analysis. So this is where my boat will start to feel like it breaks away from the water and really starts to fly. And it tells me that my boat enters a porpoise regime at about 42 miles an hour, and so I should probably check into that also, because that may not be a desirable effect. From the report wizard, I can now go on to step 3 of the performance analysis, which gives me power required and acceleration and elapsed time information. Or I can click on details and move on to see the performance results in detail, including the presentation in graphic format. So that's what I'm going to do because I love this part. So let's have a quick look at the performance results screens. There's another video that explains all the features of the performance results screens, but I want to have a quick look at the kind of information that we have here before we finish today. There are 3 performance results screens with over 450 points of performance data. Each of the calculated data values are presented for each of 10 velocity step snapshots. So let's have a look at how that works. Screen number 1, performance data, shows lift and drag information for all contributing components, which would include aerodynamic, hydrodynamic surfaces, sponsons, center pod, V surfaces, V pad, etc. So there are a lot of valuable performance measures like trim angle, dynamic stability, static CFG, center aerodynamic pressure, porpoise analysis, and power required that are presented on this screen. On screen 2, coefficient data, all coefficients and aspect ratios for every component of lift and drag, including all the aerodynamic and hydrodynamic surfaces, as well as the cowl, cockpit, or canopy surfaces, and of course sponsons, center pod, V surfaces, etc. are presented on this screen. Also, the planing surface wetted lengths are also shown for each of these contributing components. On screen number 3, even more performance-related information is shown, including the lift-drag ratios and total wetted surface areas for each of the contributing components. There's also some other performance-related information that would be shown on this screen that pertains to specific design features that might be used in Tunnel Boat Design Program, but we haven't used those, so they don't show up on this screen today. All the performance output information can be printed when needed, and the graphic screens are accessed from any of the pages by clicking on the Performance Graph button. The Performance Graph presentation feature is one of the most powerful analysis tools in Tunnel Boat Design Program. There are 34 performance graphs that show each key performance indicator as it changes through the boat's operating velocity range. We can curse from graph to graph by just clicking on the arrows above the legend. I'm going to look at the W angle or trim angle graph first, since this is a telltale of many performance issues. The graph shows me how the trim angle, shown on the left vertical axis of the graph, has to change to achieve the velocity that's shown on the bottom horizontal axis. So this trim angle graph tells me that I need to increase trim angle fairly evenly up to about 49 miles an hour, and then my boat will continue to accelerate without any more trim at all the way to about 70 miles an hour. Then I see that I need to increase trim angle more to get more velocity. The graph also shows me that as trim angle is increased for more speed, the biggest change in trim angle occurs at 78 miles an hour as the boat tries to go faster. So even though the boat may be capable of going as fast as 85 miles an hour, after 78 miles an hour or so, we may be reaching a region of unstable operation. I'm going to move to the dynamic stability graph. Dynamic stability is an important indicator of the location where all the forces acting on a boat are resolved to. All these forces include the lift and drag from sponsons, lift and drag from aero surfaces, lift and drag and thrust from the propeller and the lower unit. These dynamic forces and their locations change a lot through the velocity range, and so it's important to analyze these changes to determine the stability of the boat. I've got another video that explains dynamic stability in detail, but let's look quickly at this graph for this boat and setup. The dynamic stability graph shows me, for example, that my hull starts into its hump zone at 49 miles an hour. So this is where my hull will likely feel like it breaks away from the water and really starts to fly. There's so much more available from this graph, but let's move on. I'm going to move on to one more graph, and that's the porpoising analysis graph. The porpoise analysis is a complex analysis that tells me whether my boat is susceptible to porpoising and at what speed. On the graph, the region above the pink line is stable, and below the line is the porpoising regime where a hull is susceptible to porpoising. So for my graph on this boat, it tells me that my hull enters the porpoise regime at about 42 miles an hour, so I should check this out to see what design and setup changes I can make to alleviate that issue. There are 34 graphs that show fantastic performance information, and I won't go through all of them now, because that's not really the purpose of this video, but it is sure a wealth of insight into my hull design and setup shown on these pages. So I'm going to finish by just going back to the design input screens. That's the end of this video, showing how we can use the Auto 123 wizard to guide us through the performance analysis process as easy as 1, 2, 3. Once we get our analysis, there's lots we can learn about the performance of the boat design from the results. And here's the really great thing. There's still lots of changes that we can make to this boat setup to get faster and more stable performance out of it, and we can do it all right on the screen with Tunnelboat Design Program.